So hello and welcome to this video. We're going to learn how to find the mean of ungrouped set of data. Remember, in the last video we looked at how to estimate the mean of a grouped set of data, and if you never watched that video, you can check it out via the link in the description box below. So assuming that these are heights in centimeters, heights in centimeters of children in a particular class. So these heights are ranging all the way from 121 centimeters all the way to 133 centimeters. So I want us to use these heights to find the mean. All right, so I want us first to represent this information on a table. So one could just decide to add all these figures and then divide by the total number, but I want us to be more scientific. I want us to make it beyond just adding and dividing by the total. So let's represent this information on a table. So we're going to have a table with two columns. We have height, the height in centimeters, and then the frequency. Okay, so let's start from the lowest figure. I see the lowest figure around is 121, and then we have 122, we have 123, okay, we have 124. I don't know whether we have 125, but I can see 126. So we have 126. We also have 127, 127. We also have, I don't know whether we have 128. It seems we don't have 128. 129 we don't have. I can see 130. I can see 130, and I can also see, can I see 131? It seems there is no 131, but I can see 132. I can also see 133. Yeah, so we have 132 and 133. So I don't think there's anyone that we have left out. So let's go to the frequency column. So when we talk about frequency, we're just filling in the number. So for example, for 121, how many 121s are there? Okay, for 122, how many 122s can you see? Or how many children had their height as 121? Okay, so for 121 I can see one, I can see another one. Can I see another one? Yeah, there's still also another one. So there are three children whose height was 121 centimeters. So we have three. So what about 122? 122 I can see one. I don't know whether there's another one. It seems there's only one, so that will be one. For 123 I can see one. I can also see, oh, it seems still it's only one. Let's go to 124. 124 we have one. I don't know whether there's another one. Yes, there is another one. So those are two. Yeah, it seems that there are only two students who had their height as 124. So let's go to 126. 126 I can see one. Yeah, I can also see another one. So those are two. Yeah, let's go to 127. 127 I can see one. I don't know whether there's another one. Yes, there's another one. So those are two. So those are 2. Let's go to 130. 130, I can see 1. I can also see another one. So those are 2 also. So those are 2. Then for 132, I can see only 1. And for 133, I can see only 1 also. So let's have 1 and 1. Okay. So we have represented this information on a table. So I told you that I want it to be more than just adding all the figures together and then dividing by their total number. Let us be more scientific and more statistical. So in the last video that I was talking about, we mentioned that to find the mean, we need to get the summation of this. Alright, so let me abbreviate this height column as x, yeah, just for calculation purposes. Let me abbreviate it as x. Okay, so we mentioned that we need to get the summation of fx, that is, alright, the frequency. Let me abbreviate the frequency column as f, yeah. So we need to get the summation of the f times x column. So f times x means that we need to get another column where we're going to fill in the values of f times x and then divide it by the summation of the frequency, or the total number of figures. For this children, for this case, it's about children, so we need to divide by the total number of children, which is also the same thing as the summation of the frequency. So this means that we need another column. We need another column that we're going to call fx, yeah, simply fx, that is frequency times x. Okay, so let's do that. So we need to multiply 121 by 3, 122 by 1, and so on. So let's start. We have 121 times 3, so that is going to be, so that is 363. Then we have 122 times 1, that is 122, and then 123 times 1, it will still remain as 123. Then 124 times 2, I believe that will be 248, and then 126 times 2, that will be 252, and then 127 times 2, that will be 254. Okay, then 130 times 2, that will be 260, then 132 times 1 will be 132, and then 133 times 1 will be 133. Alright, so we have filled in the column of fx, so we need to get the summation of this column. So we're going to add all these values together, 363 plus 122 and so on. So let's do that. So the total, the summation of this column is going to be, so 1887, I believe that is correct. So that is the summation of the f times x column, and then let's get the summation of the frequency column. So the summation of the frequency column, or simply how many children were in this class. So we're going to add 3 plus 1 plus 1 and so on, and this is going to be 15. Okay, so now to get the mean, we're now going to divide 1887 by 15. Yeah, 1887 divided by 15. So this is going to give us 125.8 centimeters. Okay, so that will be the mean of the height, or the mean height of these children in this class.